Today we're going to talk about AI software factories. So who am I? Gabe Hamilton. I'm a co-founder of Differential AI Lab, and I've built a number of agent platforms over the last few years. So platforms where you build an agent, deploy it out, have it run in the world. Built an early coding harness back in the pre-Claude Code days, and recently I built a new AI software factory at Differential AI Lab. So we'll talk a little bit about that. What do you think of when you hear AI software factory? We were discussing this as a group just before this, and a couple of different things people mentioned were, it builds software for you. It's kind of in the name. Someone else mentioned that, it reminded them of the factory pattern from past, software engineering patterns you might have studied. And another take was, oh, yeah, a system of pipelines and pipes. All good things to keep in mind. Mainly, I think we're thinking about something that you describe what you want and you get a working app. So, is Replit a software factory? Is Lovable a software factory? Sure, they're certainly trending in that direction. And as we'll see in this talk, a broad number of things might be described as a software factory. But we're all pretty familiar with these processes. If you've worked for a tech company or just been adjacent to software, most companies produce some sort of software, so you've probably seen a lot of this. Where from the CEO's perspective or the chief product officer's perspective, it's already a factory. You specify what you want. You want to solve this problem for customers by building this software, and eventually you get some software out. So you've got product managers and developers and QA and SREs, an assembly line of job functions producing this software. It's just been a slow factory. We talk about having features, next quarter, next year. It's 2 years out. And, sometimes a frustrating factory to produce that software. But a lot of that stays the same. We've just been automating more of it. We've had autocomplete and copilots and agents doing coding for us, orchestrating those agents. And we're really moving into a time where factory is a good description of coordinating all of that now and coordinating that whole process. So we're talking about an increase in capability, in scale, and complexity. Okay, so what about this idea of a dark factory? And this comes to us from manufacturing. So the idea kind of proposed back in the 80s that if the factory is fully automated, if all the welding is being done by robots and the car is being pushed all the way out, then you'd know it's automated because there's no reason to have the lights on anymore. No reason to waste that energy. It can be a dark factory, fully automated. Now this, ignores the modern development that robots actually need a lot of computer vision, but that's okay. It's a good metaphor for thinking about full automation. Could we build ourselves a dark software factory where it's fully automated? We don't know what's going on in there. Would we want to? I'd say certainly we can. I mean, we already can automate a lot of processes like that and don't necessarily need to know exactly what's going on. And that's useful. It's useful encapsulation. Be able to say that I only care about the output behaviors of this thing. So I think we'll get some of that certainly. On the other hand, I think we want brightly lit factories that are collaborative spaces for automation and for people, where we can be creative and see what's going on and be able to understand the system and debug it. So I think we'll have more bright factories, but still it's a useful way of thinking about automation. Okay, so what pieces do we need in a software factory? We need specifications in, we need some parallelization. We want to be able to, really get a lot of things done quickly. And we want to produce good outputs. So we need quality control. Let's look at a couple of the different options that we have for software factories these days, AI software factories. So the first one we're going to look at here is Stripe's Minions framework. Now, Stripe has a sophisticated software factory already running, continuous integration and continuous delivery, lots and lots of humans working all the different parts of that assembly line. And what they've done is they have automated parts of that. So you can type, at minion, fix this particular bug, build this feature, investigate this thing, and then all the automation kicks off, leading to merging that PR. And their headline stat is that 1,300 or more probably now AI written PRs are merged every week. It's a pretty large amount. I mean, they have thousands of employees, so hopefully there are a lot more PRs than that being merged every week. But that's significant. And I think the key takeaway here is that we're already familiar with the software assembly process, and we can add automation to that and get really good results. So things that are good for human engineers in terms of continuous integration, continuous delivery, are also good for agentic engineering. Okay, so that's one type of factory. Here's another type, which is more, the kind of factory you might have on your desk, sort of the 3D printer of factories. If you're running something like Claude Code or Codex or Cursor, and you pair that with a good pipeline of skills to do the different pieces of this workflow, you've got a really good factory there. So that's going to be, writing the code and reviewing it, and then, making fixes based on what the review found, testing it, verifying it, hopefully doing some security review. A nice little pipeline like that will give you quite a bit of power. And a good place to get started, Every.2 has a nice set of skills for what they call compound engineering. It's going to give you a lot of those pipeline steps and a really critical step of reviewing to see, what could be improved based on how you work. So that compounding effect is really powerful. Another aspect of this is that Claude Code and some of these others have gotten really good at coordinating a swarm of agents by themselves. So giving you a lot of that parallelization all in your base coding harness. So you don't necessarily need a separate orchestration. You get a fair amount built in here with something that runs on your desktop. Let's look a little bit bigger. Gastown is a good example of a higher level coordination framework. And there's been some other ones, Claude Flow now has some new name, was an early one. And people are building these, more factory focused systems. So thinking of it as more than just a harness, but a large scale coordination task. So where you might have dozens or hundreds of agents working away on things. Now, these are definitely more complex. If you watch Gastown run, there's a lot of different types of agents monitoring each other and a lot of kind of duplicated work or work that doesn't get pulled together quite right, and then something else has to come along and pull it together. So sort of like a modern company in some ways. Um, but it's eventually kind of getting there. So it's herding all of those cats towards the goal. And that's the idea, is that it may not be super efficient, but you can pour money in and get some results out. And it'll certainly use tokens at a faster rate than a lot of these other techniques. But it's definitely nice if you've got a large scale system, you're able to write a lot of high level specifications for what you want, or kind of specify what the overall system should look like. Gastown is really interesting, gives good results. I particularly like the system of design reviews that it has initially. So you say what you want and get some specifications, and then it's going to do a good job of going through different levels of review, looking at risks, looking at all kinds of different things to get something that's a good description of what you want to build for the rest of the system to then really iterate on. So definitely a nice one to try out. I like having Claude Code coordinate Gastown for me so that some of the rough edges, I just don't have to worry about. Claude kind of papers over them. Okay, so how do we build a differential AI lab? It's a pertinent experience here. One key takeaway is the factory is not one thing. We work in different ways. We have a couple of these different sort of types of factories that we use. Often we'll just tag an issue or something, at Claude, go ahead and fix this bug, and then it's going to run through our continuous integration and our continuous delivery. So similar to the Minion system. We do a lot of work with pipelines in Claude Code. So working on a single feature or something, that's a good, that kind of factory on your desktop is a really nice pattern, easy to jump into. So we do that quite a bit. And then often we have bigger projects where we're building something for a customer and we can really spec it out and let something like Gastown or some of our proprietary software really crank on that. One of the main things we do, though, is to try to let the system search for a solution. So if we can specify a good eval, what does good look like for this system? Great. Then we can really, let our factory loose on, building toward that. And we might throw away lots of different PRs and projects that, are, uh, you know, takes at that direction, but aren't so great for one reason or another. Maybe it's too complex or like, okay, that's interesting, but not quite the approach we want. No problem. We can continue that search both within our factory and manually toward fitting our eval and getting a good solution. Okay, so how do we convey what's going on in our factory? Well, we collect events from the different pieces, and we have a fun little visualization I'll show you here. Uh, just kind of think about what all is going on. So this is collecting the different factory events. I'm going to go ahead and turn it on here. And so this is from a past build. The build might take, hours or days. But you can see we build out a bunch of specifications, different dimensions of what we want based on the original specification. And then we're firing up agents, which are represented by lasers here. So those lasers are working on different components and building code, reviewing and testing, and basically building up iteratively these components. Then we have higher level evaluations. You see some of these out here where we're now saying, okay, great. How does this thing hold up to reality? It's similar to end-to-end testing, but a little bit higher level where we're running, the whole integrated system and often rebuilding things in response. So not just a fix, but like rebuild that whole module. And eventually, you get a whole system here. Okay, so that's fun. Let's just visualize it a little bit. So what are some of the key things that you need in a software factory? Often a loop is one of the key things. Cloud code itself is mostly just a loop. It's not revolutionary, but it has a lot of power. So reviewing and then fixing, reviewing and then fixing. That's powerful. Gets you to pretty good code. Testing and fixing. Can do that. Security review and fixing. These are all really good loops to have in your pipeline, whether that's a small pipeline or a large scale one. And all that works off of quality gates. You've got to be able to test things so that you can send it back. So that might be the test passing, it might be, types and linting. A lot of people now lump a lot of things into linting, so it might be architectural linting, which still sounds kind of funny to me. But yeah, whatever your eval is, and your spec is a type of eval. So saying, does it meet the specification? Does our software do the things that we originally said it was going to do? If not, then okay, great, we iterate. Now, if you can have a quantitative eval, do the set of input documents get correctly processed, for instance? That's even better. That really lets your system work towards success. And if you can specify some sort of function for what good is, that's also really powerful. So you might want your software to be maintainable in certain ways. You want to have some of the same architectural principles that you would build in if you were building it yourself. So you might come up with some reward functions. You might say, okay, we're going to measure the cyclomatic complexity of these things. We're going to measure the coupling of these different components to see how modular our system is. Those are good evals. All right, you've got an AI software factory. What do you do with it? Some of the things that this really enables, A, building a lot of software quickly. That's certainly nice. But you can also get fast feedback on things, the ability to just kind of like print out new features or new versions of your software, new user interfaces. That's really nice. You can build custom, so you can build, exactly what you want. In the next part of this series, the next talk, we'll dig into a couple different builds from different software factories of the same initial idea. And one of those is a user group application for managing your meetup or your user group. And that's really nice to be able to say, this is exactly what this group would want in terms of features. We can build that into an application. Another great thing you can do is this really changes the economics. You can completely flip situations around. So something that might be looking at, build versus buy, like, okay, build, we got to spin up a team. It's going to cost a couple $1 million. We got to hire. Okay, great. That's one option. Or we can look at these different vendors that have software that, maybe meets what we need. Might be pretty good. Buy is often a really nice choice, especially over the previous 10 years. Buy has often been a good decision. But with an AI software factory, we can just flip that table right over. Great. Let's custom build, exactly what we want, more quickly than we might be able to integrate something that we were buying. So really changes the potential economics. You can start building today, whichever sort of factory you're choosing. These are a couple of the principles you might want to keep in mind that you're going to try to write a spec, not just a prompt. You want to detail out the different dimensions of what you want, and then you can harness a lot of tools to then turn that into reality. And often we'll try and write specs that don't specify, what particular technology stack we want. We might keep those separate, what we want versus technology stack. So then we do a, kind of a reprint in a totally different language, totally different frameworks. Building evaluations. This is a lot of what we'll be thinking about in the coming years. What does good look like in this situation? How do I evaluate that? What are my criteria? How do I make those concrete? And then closing those feedback loops, taking advantage of having put that thought into an evaluation. Now you can really harness that to search for something good. Okay, next talk will be kind of digging into this a bit, looking at the output of some different factories and looking more into the details. So we'll post that later.